So a rectangular box, and it says the volume is 1,216 cubic feet. It has a square base and top. So all these at the base are all X, and the top also X. Okay, the cost per square foot for the bottom. So for this, the cost per square foot is 0.20 per square foot. For the top, right here, the cost is 0.10 per square foot, of course, dollars. And for the sides is 1.5. So for the sides, 1.5 cents, so 0.01 dollars per square foot. Okay, perfect. What dimensions will minimize the cost? So we're asked to minimize cost. So in order to minimize cost, I have to have a function that is the cost. So number one, find the function or the cost function. So find the cost function. How do I do that? What will be my first step? How do I determine the cost? Anyone? What will be the first step?
Would it be all those things put together?
Yes. So the cost function will be the cost of the base, cost for the base, plus cost for the top, plus 1, 2, 3, 4, because the height is height, same. But there are 4 sides. 4 times the cost of the side, cost side. Good. So now let's determine the cost for the base. So per square foot is 20 cents. So the area is X times X. So this will be X squared times the cost per square foot. The cost for the top, same thing, still X squared, but times 0.10. Now the cost for the side. So the side is X times height, right? Base times height, X times age times 4. So 4 times base times height times the cost, which is 0.015. We also know that the volume is given to us. Can anyone give us the formula for the volume of this box? Area of the base times the height. So X squared times the height equals 1216. So now I'm going to use this and all this to determine the cost function of one variable only. So cost function of X. This is clear, 0.2 X squared. This is clear, 0.1 X squared. This is 4 times this, so 4 times 15 is 60, so 0.06 times X times, I cannot have age. How come? Because I only have one variable. I cannot have 2 variables. So I will replace age from here. Can anyone solve this equation for age for us?
1216 over
X squared, yes.
X
12,
squared.
yes, of course. So that's it. 1216 over X squared. Of course, I will simplify one of these. I will add these two, and I'll continue simplifying. 0.2 plus 0.1 is 0.3x squared. Here I have to multiply 0.06. Where's my calculator? What did I do with it? Because I don't want to share the screen with just this. 0.06 times 1216. I got 72.96. So plus 72.96 divided by x. So I have the function that is a function of one variable, x. In order to find max min, so after I found the function, number two, I have to find critical numbers. If the function has no critical numbers, it doesn't have max min. But for critical numbers, I have to find C prime. That's how I determine the critical numbers, by looking at C prime. Good. So this is clear. 0.6x, careful now, minus 72.96 over x squared. If you have any doubts how I got from here, please stop me now, please. Let's take a moment and look at it. Always remember, this is a formula to always remember 1 divided by x, 1 over x, this is a constant, it can stay outside. Prime is negative 1 over x squared. Please remember this formula. It's very useful, especially for the next chapter, chapter 4. Now I have to find the least common denominator. Can anyone tell us the least common denominator here? What is the least common denominator?
X squared.
Good. So then I need to multiply this by x squared. So 0.6x cubed minus 72.96. So we know critical numbers come from two possible sources. One possible source is C prime of x being undefined. No, because x cannot be 0. X is the distance. It's the base, the length of the base of the square. So it cannot be undefined. X cannot be 0. So the other source is when C prime is 0. So what do I have to write? When is this fraction 0? So I can write it.
Numerator equals 0.
0.6x cubed minus 72.96 equals 0. Move this to the other side, divide by 0.6. So 72.96 divided by 0.6. So 72.96 divided by 0.6, I got 121.6. So x cubed equals 121.6. And now, of course, I will apply that operator that removes the cube. So I take this to power 1/3. And I got 4.95. So approximately 4.95. And that is in feet. How do I know that this gives a minimum or a maximum? I have no idea. So that's why I have to show. And I show in this way. 0, of course, cannot be infinity, cannot be 0. Of course, we know that. 4.95, C prime is 0. And now I have to study the sign left and right. So we'll come back to this. I will not even look at x squared because it's always positive. I will plug in 0 in the numerator and tell me just the sign. That's all I need when x is 0, and I'll put the sign here.
Negative.
Of course. So if you decide to put 10 in here, that will be 1,000 times 0.6, so it will be 600. So this will be positive. Or you just put in the calculator and you will see the sign. Plug in a number here and a number here and you get the sign. So this is typical for a minimum. So it's guaranteed that this will give a minimum. Now when I'm asked to find what is the minimum, I do not plug in this function because it's 0, right? It's the rate of change. I plug in C of x. So what do I plug in? C of 4.95. So here's C. 0.3x squared plus blah, blah, blah. So now I will put in the graphing calculator. You know me, I prefer to see the function. So the function is 0.3x squared. And plus 72.96 divided by x. And I see it, it's correct. And now I plug in, what was it? To be exact, I will plug in the cube root of 121.6. So 121.6 and power 1/3, the cube root. And it will give me 22.09. So $22.09, the cost. 22.09 cost is the minimum. So now if you choose, so this is x, 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 x. If you choose 3, you're not going to get the minimum cost. If you use 5, you're not going to get the minimum cost. The minimum cost is only here, at this number and no other number. Is this problem understood? All steps, everyone?
Yes. Thank you.
Thank you. Good. Other questions? Anything else you would like to ask about before we move on to section 3.6? Do you need help with anything else? Okay then, so let's continue with 3.6. Few things here. Number one, we are going to talk about differentials. And you can say, this is a new word. What is this? What are you trying to say? In a minute, we'll clarify this. And the other topic is a linear approximation. So we'll get back to this in a minute or two. So let's talk about differentials first of all and what they mean. Okay, so let's take a look at a function. This is function f of x, and let's say I have here p, and the coordinates of p are x, and of course f of x. And just remember, q is very close to p. So q should be right here, very close. But I'm going to zoom in, because if I have q and p one next to the other, I'm not going to be able to explain anything. So just keep in mind, q is very close to p, and we are zooming in. I'm going to picture q here. But they are extremely close. We are zooming in. And the coordinates of q are x plus delta x, or x plus dx. And you could say, what is this? What are you talking about? Yes, the distance between p and q on the x-axis is delta x, or dx. Just dx, I can't write that. Okay, so delta x or dx. What does this mean? And then we'll continue our explanation here. So let's suppose we are creating some disks. We are manufacturing disks. And the radius of the disk is x. And the radius of the disk should be 10 inches. But the actual x is 10.1 inches. We had an error. We made an error. So the radius of the disk should be exactly 10 inches. But when we manufactured it, we made an error. What is the error? Of 0.1. So x is 10, and this is the dx. So instead of being here, I'm a little bit to the side, in plus or in minus. It can be minus. So it can be here or it can be here. So that's what Q is. So Q is the original plus or minus a little error. So the error in my example here, so 10 is the x. This point is 10.1 because the error, delta x or dx, is 0.1 inches. So first let's write what delta x represents. Delta x is the exact error or change in x value. What is dx? Well, it happens that it's the same number, same value, but called not the exact change or distance or error, no, but called the differential of x. The differential. And now you can say, why these two different names? They mean the same. It's the same value. It's 0.1. So delta x and dx are the same. Here's why. To remind us that this uses the function. And this uses the derivative, not the function. That's why it has two different names. That's why these two have two different names. Delta x uses the function. Dx is in connection to the derivative. But you can say again, why two different notations? Again, this is connected to the derivative, and this is connected to the function. Okay. Coming back here, I know you are going to say that the y value of this point is